My name is Ian Hankey. I've made some pieces out of end-of-life building glass. Container glass is usually recycled, but building glass never is. It doesn't go back into making glass. This is basically a cast piece of an object being cast about 11-16 degrees, about 400 degrees less than you would imagine end-of-life building glass to melt. And you can see I don't even need to cut it. I can just let it fall off. And the way I've done this is adding ash. And ash alongside what you can see is smashed up, it's windscreen glass actually. It's end-of-life building glass. It's kind of soda lime glass, and I've just added ash to it. But that ash I haven't burnt myself, and this is my measurements. I put the ash into the melt there. And the ash comes from a biofuel burner, so I haven't even melted anything. Burnt anything. Now what I'm doing here is I'm using a potato to mix the ash and the glass together. And this is the way they used to do it in the old days. The old glass makers used to use a potato. When it's plunged into the bottom of the glass, it produces loads of bubbles. And those bubbles rise to the top, and as they're rising to the top, it then mixes the glass far more effectively than if I tried to stir it. So there's the potato there, and you can see what we've got now is a really nice mixture of glass. The next thing I've got to do is figure out what temperature I should anneal my glass at. Every piece of glass needs to be annealed, which means put it into an oven and take the stress out. And as you can see, it's really quite long work in this. It's taken a while to stiffen. But what I need is a cane. That cane needs to be around about 8 millimeters across, something like that, so that it's fairly substantial. And as you can see, it's stiffening up as it cools. So when it's got about 500 degrees or less, it'll be very, very straight. And then we put it in the kiln and work out the temperature that it starts to move at. That's actually our softening temperature. Our annealing temperature will be about 40 degrees less than that. So we can work out basically from any glass what temperature we anneal our work. And so basically at this point we can start to make things. At the moment I'm just putting some air in, and I just trap a bit of air in the iron and it'll blow through. And it's behaving just like a studio glass, which cost me around about £3,500 to £4,000 a ton, depending on what we use. I'm gathering over it to get more glass there, to get more weight, and shaping that up. And what I've got to do, of course, is center it on the iron. And you can see it moving away there. So it's actually behaving, as I say, like a kind of paid for studio glass, which we have to import. We don't make it in this country. And so my thinking is that if I can actually make glass and use waste, and that waste can be quite harmful as well if it goes into landfill, especially when we think about solar panel glass, that kind of thing. So I'm just basically getting it on center, and then I can start to blow and start to fashion a piece of glass. And there you can see it getting slightly bigger. And it goes back into a reheating chamber. Incidentally, the furnace there I've made, it's all from repurposed materials. I'm just using gravity there and heat just to stretch it, and I'm going to blow it. The way the glass has been made for hundreds, if not thousands of years, actually. But the furnace, as I say, that's a pedal bin I'm using to reheat. There's no burner on it. It's fed directly from the furnace. Rather like it was done back in the Renaissance times, everything in one basically. And then I can start to blow and fashion the glass. So I need to put a flat base on the bottom of that so it'll stand up. Oh, I also need to cut it in to make sure that it will actually come off the iron. This is kind of a weakness that you put in. You a little bit of water on there, and when you hit it, you put a little bit of water on it, should knock straight off. So I just need to heat the very end of it, really. It's a little bit big there, so my pedal bin has actually got a collar which can be taken off, and it's a little bit bigger now, and that will go in. So around about £500 worth of recycled and repurposed equipment there. Behind there, of course, is a very complex burner. So now that I've got the very tip hot, I can just flatten the base there, so it will stand. Just push that in a little, and now I can use a file after I've cut it in. Get a file there, and I can score that edge and possibly put a bit of water on there, and that will cause a bit of thermal shock, so it should break off exactly there. So this is the way the glass was blown hundreds if not thousands of years ago. And there you have it, a demonstration of just a simple blown object. Now I'm just setting up a small piece of glass here, which I'm going to gather over in a second, and I'm going to actually try and make a swan. I haven't done this for many years, but a swan is traditional in England, in English glass, because if you went for a job, they could tell straight away how good a glassmaker you were by the swan that you make, whether you can make the whole thing without reheating it. So the idea is to fashion this it's a solid piece of glass, and fashion it as best as you can without a reheat to try and make something that looks like a swan. But I think this is quite a good demonstration of the glass, that this glass, which is normally not able to melt and recycle, you'd need about 1600 degrees, 14 to 1600 degrees, and our furnaces are not capable of melting that to be able to reuse it and to recycle. What I've done, of course, is I've changed it. I've changed the chemical nature of this glass, but only by adding ash from a biofuel burner, a biofuel boiler. So I've just taken something that is a waste that's going to be thrown away, and I'm adding it to waste glass. And it's saving me basically up to £4,000 a ton, and also saving the trucks on the road and having to buy things from abroad and import in. And what we've got now is a very beautiful piece of glass to work with, and it's a very soft working glass, and a little blob on the bottom there, and you can see a swan there manipulated. And this is our testing that Dr. Sarah Fern at Imperial College did, just to prove that glass is softer and does melt at much lower temperatures. And we have the colour, the manganese, and also a bit of iron oxide has come from the ash itself, so we can actually colour our glass or decolour it. So a very successful melt there, and some very beautiful objects coming from what's basically industrial waste that is quite harmful to the environment. And as you can see there, blown objects, stretched objects, in a workshop that was crowdfunded and not actually created by industry.